Welcome to Google Developers Live. We're going to be talking today about Encrypted Media Extensions, which you may also know as EME. My name is Sam Dutton. I'm a developer advocate for Google Chrome, based here in London. And I have with me today John Luther, who is a product manager for EME, amongst other things.
Good afternoon, good
morning,
good evening, wherever you are.
Wherever you are. I was just wondering if you could kind of tell us a bit about your background and I know you're working on other stuff as well as EME.
Yep. So let's see, my title is Product Manager, Chrome Media. So right now I manage all the video technology in Chrome, as well as the WebM project, which is an open media format. People might know as VP8, the video codec, Ogg Vorbis audio. So anyway, okay. I manage that stuff, but my background is primarily in digital media and specifically in compression.
Right.
I worked for a small company called Onto Technologies from 2002, and then in 2010, Google acquired Onto and open sourced the VP8 codec that we had, and that became the WebM project. So now WebM is really the first, sort of the highest quality free media codec available today. So we're pretty proud of that. But anyway, yes, so EME is part of what we call the video stack in Chrome, sort of all the innards that make media happen, and that's my responsibility.
Okay. So we've got all this video coming to the web.
Oh yeah.
The stats are incredible. How are we going to cope with that? How's the web going to cope with all this video?
Yeah, there was a study done by Cisco called the zettabyte era. I think that was last year. I think they update that study every year, but their projection was, I think, something like, by the year 2016, some astronomical percentage of all traffic on the internet will be video. It's like 80% or something like that. But anyway, yes, it's becoming a big issue. And as we know from YouTube, I don't even know how many hours of video per second now come into YouTube, but it's a lot. So there's sort of two things that we're working on. First is adaptive streaming. We think can at least the quality of service of this. So today, shortly a few months ago, until we started deploying all this stuff, a client getting a video would be sort of a single stream at one data rate, meaning there would be so much data per second to serve that video. And as we know, network conditions vary a lot. Like, if you ever look at a bandwidth monitor on your own machine, your available bandwidth just fluctuates all the time. Yeah. So adaptive streaming, what we can do is we can sort of figure out what your available bandwidth is at any moment and serve you the right video stream at a data rate that's more appropriate for you. So as those conditions change, the data rate will be going up and down. And so anyway, this is starting to be deployed on YouTube. And in Chrome, we have an extensions to HTML API that we proposed called Media Source Extensions, which enables developers to do this in their web apps. The other thing that we're really psyched about is the VP9 video codec, which is the successor to VP8. We finished defining that codec in June, and now we're optimizing it and integrating it. It's now in Chrome, it's in the beta channel. And that we're seeing, results of, about, if you're familiar with the H.264 video codec.
Sure.
Just as sort of a benchmark, at VP9 we're seeing quality about 50% better.
Okay.
Than the highest quality, high profile H.264, which is their sort of, highest available. And then, there's now an emerging standard called HEVC. We're seeing VP9 slightly better than HEVC, and we're still going to keep working on optimizing those things. So it's pretty exciting. It's, if you look at that earlier thing I mentioned, the Cisco study, and you say, okay, well, we have this exploding volume of video on the internet. If a codec like VP9 can shave half that off, you've just doubled the size of the internet in a way, and that opens more capacity because this is going to keep growing and growing. Especially with high definition. Now people are talking about 4K video, which is just mind-boggling to me. So anyway, those are two of the things that are going to help. But we're always looking into, we're doing research just how to make the user experience just better for online video. That's also one of the missions of our project.
So going back to VP8, I know there's been some work on hardware with VP8. I'm just wondering, tell us a little bit about that, because I know you've been involved with some of that.
Yeah, one of the virtues that I think I have from working in this business so long with video compression, and the hardware it's an important part of the whole ecosystem, but hardware, as we know, takes a long time to develop. So to get a codec from definition phase to implementation in software to hardware, you're typically talking about a 3-year timeline. It's a lot. We think it's too long. We're trying to do things to shorten that that time frame. But what we're starting to see now is, we open sourced VP8 in 2010. We excuse me. We launched it at I/O. So now that 3-year period is beginning to elapse. So you might, the Samsung Chromebooks that we launched last fall, the very thin, light ones, they have a Samsung ARM platform in them that supports VP8 decoding in hardware, for example. Same is true with the Nexus 10. The Samsung S4 phone that just launched has VP8 decoding hardware in it. Yeah. So there's Qualcomm and Broadcom. There's a whole host of these vendors are starting to ship SoCs, SoC, system on a chip, that have VP8 decoding blocks, and encoding blocks are starting to come too. So you're starting to see that happen, and with VP9 we've already been discussing this with vendors even before it was strictly defined, and their response has been they're very excited about VP9. YouTube has a lot of plans for VP9. So these are some of the things that drive the hardware development. And we also have a whole team of engineers in Finland who their primary work is to design hardware codecs that these vendors can implement, and we license those free of charge. So there's all sorts of hardware things going on.
Some really interesting stuff coming out of that. By the way, we've got some slides online, and I'm going to show up on the screen the slide URL that can show you some kind of demos and so on. If you want to read more about VP9, there's a great presentation at Google I/O. There's a link to it there in the slides. We're talking a bit about full screen as a URL for a full screen demo there. I just wanted to briefly kind of show off the media source extension stuff. So if we just go to another.
Yeah, cool.
I just wanted to show this in action. Essentially what's happening here is we're getting chunks of video and then playing them out in a video element here. So getting the chunks with JavaScript. You can kind of see the code there, a little bit difficult to get to. But check that out. It's pretty straightforward if you want to have a look at the code for that. And it's a good place to start. So I really wanted to kind of get started with just kind of an overview of what we're doing with EME, Encrypted Media Extensions. Getting back to the topic.
Well, that's okay. There's so much going on that it's hard to keep it all to one subject. So, EME, Encrypted Media Extensions, is a JavaScript API to allow playback of encrypted media. Mm-hmm. Now, this is a W3C proposal for EME that's been been implemented in Chrome. And the important thing is that it extends the HTML media element. So, in other words, this is an extension to the functionality of video and audio elements. So I guess the kind of first question that comes into my head is, what is the problem that we're trying to solve with this? Sure. The problem, HTML5, when I first came to Google in 2010, and even prior to that, everybody was talking about HTML5 and getting very excited about it because, there's traditionally, and from my work at On2, we were involved with Adobe and Flash. We had the first, for what we called high-quality video codec in Flash, which was called VP6. So, as the technologies were emerging and HTML5 was coming on, and the video element, everybody was very excited about it. But once we started talking to developers and other vendors and things, they said, well, yes, it's a very compelling story, but it's lacking. In other words, a lot of them said, we don't want to rely on these runtimes. We don't want these mysterious things that run in the object tag, and they might have security problems, but at the same time they wanted all the functionality that those things had. So the things that they thought were missing were things like full screen. For various reasons there was no full screen provision in the media element. Adaptive streaming, what you just showed, that wasn't, it was sort of like video was almost sort of like the image tag. It's just video source equals that file.
Yeah.
Play it as fast, whatever. And then what a lot of them said is, we want to serve paid content. The copyright holders of that content have certain conditions. They're called robustness requirements that playback agents, clients, browsers must satisfy. So they said there's other, use cases that we talked to some people who wanted to do corporate training, things that were private to their company, but they didn't necessarily have to, lock it down. They still wanted to do an encrypted stream using HTML. So that's something. This word kept coming up: encryption, encryption, encryption.
Yeah.
So we looked into it, and we said, well, it's probably not the main HTML spec is not the place to propose this. So we proposed the EME spec. Full screen was proposed by Mozilla and Google, and that is now I think a W3C RFC. It's a standard.
Yeah,
it's so EME
widely implemented. Yeah.
We collaborated with Microsoft and Netflix to write that spec as well as the media source extension spec.
Okay.
And have implemented both in Chrome. Microsoft has implemented them in IE 11, which they've announced recently.
Right.
And so that was sort of the problem, I guess, was just bringing the web platform to feature and functionality parity with traditionally, plugins, runtime, more accurately, runtime plugins, things that we're doing all these things already, and they said we need the same functionality in the web platform. That's how it all kind of came together.
Okay. So the technology we have, which is now in Chrome and not behind a flag, or can be disabled, I believe, from behind a flag.
Yep. Yeah.
Is the technology codec dependent? Is it important what codec we're using with this, or is it?
In Chrome, we support WebM is our preferred format, of course, because it's open, and we also support H.264. But it's the specification itself is not dependent on any codec. I mean, it's really up to the implementer, the browser maker, which codecs they want to support. But it's not a determining. It's in other words, it's the video tag itself that is going to render the content and decode it. I mean, in other cases, the CDM, which we can talk about later if you want, we'll do that. Yeah. But the short answer, is that it is not codec dependent.
Yeah. Okay. So I guess the kind of maybe the best way to begin with this, if we could go to my slide. I've got a rather complicated overview of this, but I'm going to try and sort of talk through an overview of this, of how EME works in practice with the API flow, and then I can get you to go into some more detail about some of the stuff I'd like to know a bit more about. So just working through this from start to finish, imagine you have a web page, a web app that has a video element in it, and you want to be able to play some media in that element, but the media is encrypted. So what happens with EME is that when the video is being parsed, the browser can detect that the media is encrypted. We'll talk a bit more about that.
Sure.
And the browser then fires what's called a need key event. And once the application, so your web app with its video element, receives that event, then it can go through the process of getting a key in order to interact with the browser, and we'll talk about CDMs, in order to decrypt the video and play it out again. So it's this process of realizing that media is encrypted, and then getting a key, getting the media decrypted, and then playing it out once that happens. So if we go to a rather more complex diagram here, John can kind of talk us through this in some more detail. I have some more questions.
So this diagram is showing another. I mean, like I said, there are a bunch of use cases for encrypted media in the browser. One of them is for paid content and rights management, as I mentioned, these requirements that copyright holders have to license the content. So this is a case of a CDM that we have created and are now shipping in Chromebooks. which is based on Widevine, which is a company that Google acquired, I think 2011, somewhere around that way. Anyway, so this content decryption module, these modules have essentially 3 functions in software. There's the license acquisition.
Right. So this is a plugin. This is a Pepper plugin in this case.
In this case, yeah.
Yeah.
So
the example here.
in software, it decrypts the encrypted video, and then it decodes the bit stream, the video bit stream, and then it hands the raw frame data to the video tag for display.
Right.
So now a CDM doesn't have to do all 3 of those things. For example, if you have hardware on the device that can do the decryption and decoding, you can do it there. There's some other provisions that you have to do, but essentially the CDM's job is to get a license with the key to decrypt the video, do that in an encrypted manner across the internet, and then decode and decrypt the stuff.
Okay,
that's its basic.
So for the non kind of video buff in the audience, could you? One thing I just wanted to clarify is that they're kind of confusing terms, like the difference between decoding and decrypting.
I know. I'm sure there are a lot of people out there that are that think they're the same thing. All right, and I actually, I talk I have a tendency to go really nerd on this stuff because I worked at RSA, which is an encryption company prior to getting into video. So anyway, decrypting. Encrypting data, you just take it and you sort of scramble it up so that somebody can't use it or read it unless it's been descrambled. So decrypting is the process of descrambling something that's been scrambled using encryption technology.
Okay,
Decoding is more accurately called decompression. So you have a video frame that has been compressed with a codec like VP8, to make it much more efficient to transmit it over the internet. Raw video is very big. Compress it down, transmit it over a network or an optical disc, whatever. To restore it, to show it to the user, you have to decompress it, which video people like me call decoding, but it's more accurately sort of like a zip file, but it works in a slightly different way, but you're just restoring it from a compressed state back to its
full
it's not quite its original, because like all compression, some data has been lost, but you're giving it, you're restoring it to the extent that you can show it to the user. Anyway, sorry about that.
Two things immediately spring to mind. The first is how does the browser know that the content is encrypted? So part of the, as you said, the parsing, sort of and again, these terms of art keep the demuxing, the kind of, let's see, what is this file, what is its property, sort of. There would be part of that header, elements as they're known in WebM, Matroska. Anyway, say this has encrypted elements. This file has some encryption in it, and then that's what sort of, as you mentioned, starts the whole process with saying to the encrypted media extensions implemented in the browser, we need a key for this. You know how to do that, and also the application developer. I mean, I should mention that a lot of this, and the reason that we designed EME and MSC in these ways is so that we want to keep as much application logic as possible in the hands of the developer with JavaScript, HTML. That's really want to keep this stuff above the browser stack as much as we can. So so that's the application developer, you can do all sorts of stuff once these events start to get fired. But that's really what starts the ball rolling. Is I have this kind of
this media is encrypted
container.
We need to get a key to decrypt it.
Right.
Let's do that.
and from what I understand too, it's possible to that you don't have to encrypt every single frame of the video, which
you could. I mean, it can be very granular. I mean, you could even encrypt what are called slices of a video, just specific parts of a frame. But if you wanted to do sort of more of a lightweight approach, you could just encrypt the keyframes. So, in other words, and again, this is getting into the parlance of it. So in a compressed video stream, there are frames that are the full picture, and then there are frames between those that, for the sake of efficiency, redundant data has been removed from them. So to reconstruct any of those, they're called inner frames, between keyframes, you have to reference back to a keyframe. So if you encrypt all those keyframes, you have a very hard time restoring the inner frames if the keyframes are all encrypted.
Yeah, yeah.
I mean, there might be, parts of it, but yes. So encrypting the keyframes is an approach.
Obsessive you get, I guess. Yeah.
Right. Yeah.
Yeah. So looking back at the diagram of the architecture, we have we've got in this case a Widevine CDM, and we have a Widevine server for the key process, so for getting a key for decryption. Could you just talk us through a little bit about what in this diagram the Widevine server is, what that's doing? Because I guess there could be confusion with Widevine, that we have the Widevine CDM and then the Widevine key server as well.
Yeah, the server, is managing the keys that are necessary to decrypt the content.
Yeah.
There could be, it depends on implementations, but that might be one key. But also, there are other approaches where you can change the key every so often if different sections of the video can be encrypted with a different key. So part of, really in the case of like a Widevine situation, what you're really doing is acquiring a license. Part of that license is the key to decrypt the content. There are other policies that can be included in the license. But primarily that's the job of the server is, it knows the relationship between the encrypted streams and the keys that are needed to decrypt them.
Yeah.
I guess I should clarify that it doesn't do user authentication. That's sometimes what people think, well, it knows who I am. That's not really true. We, again, keep everything above the stack. We want all user authentication, those authorization, those sorts of things to be handled in the application. This is just to get the key. That really, again, all of it is
single task.
Get the key. Yeah. We need to decrypt this thing. And in Widevine, that CDM can enforce rights management policies, but really, again, the primary job is get the key, decrypt the video, show it to the user.
Sure. And the decryption of the video is actually happening. In the CDM plugin.
In the case of software, yeah.
Yeah.
In the case of hardware, and again, this, you want to do as much of this stuff in hardware as you can because of the efficiency, the battery, battery-powered devices like tablets and mobile phones. If you're playing video in software, it tends to use more energy from the battery than doing it in hardware. Any as I'm sure our audience knows, any specific hardware, does a specific function is much more efficient to doing it in software. So, but yes, in the case of the Widevine CDM that is deployed in Chromebooks and is coming soon to desktop Chrome and also Android, it's doing these things in software.
Okay.
Next step is doing as much of it as we can in hardware.
Okay. And from what I understand from a sort of basic implementation of EME, we have something called clear key encryption. Can you just talk us through that, how that works, what that means at that level?
Yeah, clear key, that means that the key itself is in clear text, but that doesn't mean that, in other words, the transmission of that key, the acquiring of it, is left to the application again. So, excuse me, in the most basic form of an EME implementation, it's sort of analogous to encrypted HLS. The adaptive specification that Apple published to the IETF. Yeah, sort of like it's just an encrypted stream. All it needs to do is get that key and start decrypting it. So in a clear key implementation, all you're doing is transmitting that key in whatever way. Once it's on the client, then it can start decrypting the video.
Yeah.
It's in other words, it's slightly different from like a Widevine CDM scenario where it's not only getting a key, but it's also getting a license, rights management stuff comes into it. Clear key.
Okay.
Clear key can be done with no CDM whatsoever. All done in the browser. The application gets the key. It's all 100% done in the browser. No CDM required.
Right. Sure. So we're kind of the simplest possible way into.
There are use cases for it that you've gone to sleep. Okay.
Gone to sleep.
Very. Again, though, we talked to people and they said they just want to do some basic encryption like you can do with HLS, encrypted HLS, like you can do with RTMPE in Flash. And that, was the simplest use case and also conveniently the one that could be done entirely in the browser with no reliance on any other technology.
Right. So to be able to implement something and test stuff out. And
Yeah, test stuff or even production. I mean, there are
Yeah.
production use cases for it, like like the corporate video thing I mentioned, or anything like that. So.
Yeah.
Yep.
Okay. I think what would be nice would be to actually demonstrate EME in action. Let me just, if we go to there, that's pretty good on the desktop.
Oh yeah. Okay.
Nice. Okay. So I guess John, you could talk us through what's going to happen in this.
Okay.
We can bump up the size a little bit.
So this is a demo that our WebM team put together, specifically a guy named Frank Galligan, and also some team members from our Chrome Media team in Kirkland, Washington. So anyway, what is happening here? This box where it says load MPD file, that is a manifest for doing this adaptive stuff that we talked about.
I have a link to that here. Hang on, let's see if we can see that.
It might want to open it in a text editor down here.
Thank you. Yes.
It's sort of a, it's an XML. This dash is, we should also mention, is a I think it's now ratified as a standard through MPEG for doing adaptive streaming. So what we've done is with WebM, we've done a dash-like implementation because the dash spec itself is not doesn't call out WebM as a format, but there is a provision in there for doing formats other than MPEG. So anyway, this file is saying,
so okay, so let's bump that up so we can see what's going on. Okay,
so this is, XML, as people I'm sure are familiar. So you're just specifying, okay, here are the URLs of the different bit rates of video. So, okay, this is the, you give them each IDs and you give a range of where their indexes are. So you can figure out, the index of the file. So and then what this is really doing, the way that this demo is doing it, is just byte ranges of the video. Other adaptive implementations, like when you created the content, you had to physically.
Yeah, no, I remember that. From the early
10
days
second
of HLS.
Chunks. This is one of the things that it became. We talked to content providers and YouTube people. They said this is managing these files is unbelievably complicated.
Yeah. So anyway, you just have one file.
You just say, okay, I know the index of it, and if I want to, anytime I want to switch, I can get the next byte range.
So what we're seeing here is a bunch of essentially URLs and byte ranges for the different segments of the video.
Yeah, and it's saying, okay, so anytime you want to switch to another, if we detect, or if the application more accurately detects that the user's bit rate has decreased, or their available bandwidth has decreased, it'll serve them a lower bit rate. I think everybody can.
So let's load that up.
You can zoom it, maybe some people.
Okay.
Because this is.
Hopefully, still see that if I make it a bit bigger.
Okay. So this, what you're seeing in these red bars below here, and I hope the audience can see this. You see these green blocks as it's playing along. What that's saying is, okay, the green means I'm now playing that data rate. So it started low, which typically in an adaptive case you do, because you always want to start at the lowest, because you don't know really that much at that point. But as you learn more about what the user's bandwidth is as you go through it, and if you see here, you've limited it. So if you bump that up or down, either way.
Let's bump it up and see if we get some more.
It might have to wait until there's a next keyframe to bump it up.
Okay.
So anyway, but see, now it's starting to climb up.
Gotcha.
Now it's up to 1488. Right. So then if you maybe try to
take that down.
Take it down to 300 and see.
Just mute that.
Sorry. That's
slightly noisy.
So this.
So that's okay. Now we're getting to 256.
Okay, so it's is it dropped? All right. Anyway.
Yeah, that's dropping now.
So this is all being done in the web app. None of this is other than the MSE, the media source extensions, which allows again the chunking, which I should mention can be used for things other than adaptive streaming, like nonlinear video editing in the browser, all sorts of nifty stuff you can do.
Okay. Well, like sort of like time shifting and stuff.
Or anything that just that you take a chunk of video and do something with it, and then even hold it in the buffer and do something with something else. And yeah, there's all sorts of things that can be done with MSE in addition to this. So there, now it is. Now we're back down to 256.
Yeah.
And I don't know if people out there would be able to see this over.
Yeah.
But the quality has decreased because you're only down to 256. It's still pretty good because VP8 is, you know. But anyway, so you know, this is the practicality of this is that it enables you to use this same player, this same quote, you know, this application to serve to someone on a 3G network, or maybe even a 2G network if you had very low data rates. But also the same app is serving people who might have a 20 megabit connection or 40 or whatever, or Google Fiber at home, where you can then serve them a really, really high quality.
We get this kind of seamless shift between whatever works.
And
depending on the context.
Constantly, you know, figuring out what's best for the user, and they don't even. In most cases, you're not going to have very drastic, like from 256 bumping up to 10 megabits. But it, you know, it just is able to provide the user with the best. You know, because in video, the higher the data rate, typically the better the quality, because you have more data to work with from the compressed streams.
Yeah, that's brilliant. Okay.
And this demo is actually also using the clear key encryption.
Right. So this is like I guess is a great place to start if you want.
Yeah, this is everything rolled into one.
Get your head around.
And I think this one had captions.
Oh yeah, I think
maybe we
did it. We may have got rid of them. Yeah. Has
might
it got
have been
the
that's full screen if you want to do.
Yeah, I don't know if we've got nice full screen action going on there.
So this is all HTML.
I don't know if we've got a track element in this, but
I thought there's the part. This is part of the full screen API is, you know, the permissions of it lets you know you're now showing the full, you know, that's taking up all the real estate of your machine. And I mean, my understanding is that's one of the reasons why there was no full screen provision in the original HTML spec, because people had security concerns or something. But anyway, it's been solved with
because you have this explicit opting in at the time.
Yeah, the full screen API has brilliantly solved.
You can check out the example in the slides actually if people want to have a look at that. It's a great API. I'm a fan of this because it has every aspect covered. We have events for going full screen and leaving out, moving out of full screen. We have CSS for when an element is full screen. We also have this flexibility whereby you can full screen an entire page or a single element, which is very handy for a page like this where we might want to full screen the video and not just full screen the entire page. That's great. So that's a good place to get started if people want to kind of look at the whole whole world of EME. And
there's no Swift file there. It's all HTML.
Yeah.
You right-click, view source, and you can see everything that's going on there, from the media source, adaptive streaming, the clear key encryption, full screen. It's all there in plain text. Anybody can look.
That's good stuff. It's a nice video too. So I've got some links up on the screen now if people want to have a look at the Encrypted Media Extensions spec and the Media Source Extensions spec, both on the W3C sites there. Some other links to various bits and pieces, including, I've gone to a different page, including the Media Source Extensions demo that we showed you earlier on. There's some demos you might want to look at there, the example we just gave. There's some other stuff using Dash and MSE as well. And there's the original demo we had with a blip from earlier on. Yep. So thank you very much, John.
You're very welcome.
We will be, I think, doing some more of these GDLs in relation to EME and keep up to date with the state of implementations and talk through some more about implementing EME in apps on the web.
Great.
So
okay. Thanks very much.
Stuff.
Thank you, everybody out there.
Thank you.